Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to a very special stream for me. I was looking forward to this for the longest time. We have a special guest today, Sauraen. How are you doing?
Hi, I'm doing all right. How about you?
Good. Yeah. So for people who don't know what we will be talking about, a brief summary is over Summer Games Done Quick this year, there was this tool-assisted speedrun, and that was like, for me, the most amazing piece of art I have seen in a while. It is a technical feat, it is amazing visually, and it is a bit emotional at the end. So it is an amazing piece of art. It is not just a speed run, it's not a ROM hack, it's, I think, its own form of art. It is really an amazing thing. And it is a bit of music and gameplay, and I guess for the most part, it is just really technical and deep. And in many videos, Sauraen shared lots of interesting information about how that worked, from what parts of the run were in the cartridge and just pulled out using code, and what parts were created from scratch and whatnot. But I was curious about the technical details, not only how can you exploit the game to run arbitrary code, but also looking at the code that does it. So looking at the code for the bootloaders, looking at how you can compose and arrange music in Reaper and then have that play in the N64. We have lots of things to talk about, and it was really a highlight for many people. Many people thought that this was the best run they have ever seen. It helped raise more than $250,000 for charity. It was like the most amazing thing I have seen in a long while. And the director of all this is here with us today. So that's why I'm so excited about this stream. And I think that for people who know next to nothing about what happened, they should go and watch the many videos that exist about this, from the run itself to all the explainers. And you have been a guest before in some other streams explaining some of the high-level technical details. So I thought today we can just leave all of that as homework for people who are interested in this, if they want to watch this more technical, in-depth explanation of what went into the speedrun, and we could just dive into the more technical aspects. And I think that we are going to split this in two parts. First, we could talk about the music, because I think that that's how we started into all this, and then talk about the code later. How does that sound?
Yeah, sounds good. The reason for the split is because I do the music ranging and stuff in Reaper on Windows, because most VSTs and stuff do not have Linux versions. And then like all of N64 development pretty much is done on Linux. So even if people have Windows, they install WSL or something. So then I'll be switching over to Linux for that. Yeah, I do think we should give a little bit of background, just for those people who have never heard of this and know you and follow your stuff but don't have any idea about this. Is that sound good?
Yeah.
All right. So Where do I start with this? Three. I guess there's sort of three separate pieces that join together to make Triforce percent, and the whole idea of the project. So starting with in speedrunning, you can do glitches. There are glitchless categories in speedrunning. Some people will do speedruns without glitches, but most people will use glitches. So the sort of the definition of what counts as like fair game in a speedrun for most categories for most of the time is just you sit down at a game console with a controller or maybe multiple controllers, whatever. You're using the original cartridge, unmodified ROM. You don't solder anything into the motherboard. You can't modify any of the hardware in advance. You can't modify the ROM in advance. You just sit down at the game, you press buttons on the controller, and then things happen in the game. And you're allowed to use glitches. You're allowed to do whatever you can do by just pressing buttons on the controller, but you're not allowed to modify anything in advance. But if you can use glitches, and you can use glitches to radically change the game and skip huge amounts of the game or whatever you want to do, that's all fair game as long as it's just controller input. And so one sort of like the holy grail of glitches in any game is an arbitrary code execution exploit. You might know this in like computer science or internet as remote code execution, or basically somebody exploits your computer through your web browser or a virus or something like that. That is the equivalent in the computing context. But in the speedrunning context, it means doing that, getting your code to run on the game console, but just through button presses. Obviously, if you use a flash cart or you modify the ROM or something like that, obviously you can get your code to run on the console. That's not interesting. That's not a speedrun. That's just you're modding the game, and that's fine, but that's not a speedrun. So in the speedrunning context, there are some games that have had a ton of effort put into them where they will find, the community has found an arbitrary code execution exploit, which means you sit down at the game console, you press buttons on the controller, you do things in the game, and somehow through that process, you get the CPU to execute usually just a couple of instructions that you, the player, have written. So for example, in Pokemon Red and Blue, your inventory is laid out in memory as a series of bytes. You have one byte for an item ID, and then one byte for the quantity, and then a byte for the item ID for the next item, and the byte for quantity. So if you use normal in-game actions to get item 5 and you get 27 of them, and then you have item 3 and you get 4 of them, then in memory you've spelled out 5, 27, 3, 4. And if those numbers also happen to be the instructions for some Game Boy Z80 assembler that jumps to the ending of Pokemon, then you do some other set of glitches, get the CPU to jump there and execute that inventory as code, and then it jumps to the ending, and then you've beaten the game. So like that's how arbitrary code execution is usually used in the speedrunning context.
How often do people find these kinds of exploits in games? I know of Pokemon.
How often?
I know of Pokemon. I know of Ocarina of Time, and I think I remember seeing a test bot block that was like streaming a Skype call into a Super Nintendo. So that was probably Super Mario World. But are there many other exploits, or is it a rare occurrence?
It's I would say it's pretty rare, but most of the games that are like older games that have had a ton of attention put into them have ace exploits now, because they had so much attention put into them. So on N64, the games with ace are Ocarina of Time and Majora's Mask, and then Pokemon Stadium. And the way that the Pokemon Stadium ace is done is by using Pokemon Red, which you can connect to the game, and doing arbitrary code execution in Pokemon Red in the like in-game emulator, and then creating a corrupted save file, which you then transfer to the N64, and you sort of break out of the emulator, and then you can get ace in the game. But in anything like N64 and later, it's very, very rare. For like Super Nintendo, it's definitely in Super Mario World. The world record is 42 seconds. You just go into the first level, do a bunch of things, and you beat the game because you set up ace and then you do execute ace. There's ace in A Link to the Past. I think there's ace in Mega Man X. Maybe, don't quote me on that. And then for NES, there's like Super Mario Brothers 3, Zelda 1, like a lot of the more popular games, the Pokemon Red, Blue, and Yellow, I'm not sure about gold and silver. Probably, yeah. There's no ace in Mario 64 yet. That's a big one, because if we could do that, that would change a lot for that community. But yeah, so ace is a thing. You get arbitrary code execution. You write in your own code. Normally, so for Ocarina of Time, you use this exploit. It's a use after free. So Link is holding an object over his head. He has a pointer to the object. Every frame, you're walking around. It's updating the position of that object. It's writing to memory. You do some glitches. You get the object that Link is holding to unload. And so then Link is just updating what was the rock or the object he's holding, but it's now updating unused memory in the heap. And then you get something else to load into the heap there, and it starts overwriting the code for that other item. And so the world record is like just under 7 minutes for Ocarina of Time, because you have a 4-minute intro cutscene and you spend three minutes like throwing random objects around to rearrange the heap in a specific way, and then do a couple of glitches and then jump to the ending. So that was the arbitrary code execution exploit in November 2019 was discovered in November 2019. And I started Triforce % less than a week later.
So I guess this is a great place to highlight that this was a community effort. And that's another reason why it makes so much sense to have that message in the ending. And you are not the person who found this exploit, right?
No. There was, dozens of people working on this, and a couple of people initially found it, and then other people came up with better ways to do it, and then other people came up with improvements on that, and it moved on from there. And even for Triforce % by itself, that was 25 people over 2.5 years working on this. So yeah, not just me, though I was sort of not just in charge of Triforce %, but like made a lot of it.
You were the person in the YouTube comments saying, now that this exploit exists, we should do this and that, which ended up being Triforce %.
Once, I guess a bit more background. I don't want to take all of our time talking about the background, but we mentioned Pokemon, there's another person, Mr. Cheese, who actually did work with us on Triforce %, who used arbitrary code execution in Pokemon Red and Blue to put Mew under the truck. So there is an urban legend that there's this truck, you could push the truck with strength, and then you would find Mew underneath the truck. And so he used Ace and then wrote in that little storyline. I mean, it was only like 15 seconds or so of like custom content, but he made that real through arbitrary code execution. Not a modified ROM, just press buttons really fast, and then that urban legend came true. And so then I commented on that video like 5 years ago saying, I hope we can get arbitrary code execution in Ocarina of Time so that we can program in a cutscene where Link gets the Triforce. Which of course now if you're watching this and you don't know about Triforce %, that's what we did. We programmed in a whole plot leading to the Triforce that's based on a bunch of beta content. Some of this beta content is actually left in the cartridge and we're just sort of loading it and showing it. And then some of the beta content was like stuff that Nintendo had made back in the day, but then wasn't actually left on the cartridge, so we recreated it. And then some stuff was just urban legends, like beating the Running Man. Well, what happens if you beat the Running Man? Then he comes out and fights you, and then you have to kick his ass and everything.
So I have a question about this, actually. You said that some stuff was left in the cartridge, and that is surprising to me because they were working with lots of constraints back then. The cartridge is not that much data, and still they left stuff there. And of course, you were not working for Nintendo back then, but can you guess as to why they left the content there instead of trying to save space and potentially save costs?
Yeah, so, I mean, the obvious thing is just like, they didn't know what was and what wasn't used. So like there's little, if you have some little bits of code or whatever, or, team person A made this thing, or it's like part of some object or whatever, and then the person who's going through it doesn't actually know if that's used or not. There's also things where like, let's say the R-Wing actually is referenced in the code, just the code path that will cause it to load can never get activated. And so they ran some automated tool to see like, is this ever used? And then it said, yes, it's used. And then they don't remove it from the ROM. So there's those kinds of things. But also ROMs are in power of 2 sizes. So Ocarina of Time is 32 megabytes. It wouldn't have fit in 16 megabytes. It doesn't matter how many megabytes it is between 16 and 32. So there's no incentive to like save little bits of, take out everything they could unless they were like at 33 and they had to get it down to 32 or something like that.
And about these exploits, do you think that Nintendo could have known about any of these, not just the arbitrary code execution? Because I think that may be too obscure, but there are so many glitches in Ocarina of Time. Do you think that maybe they knew about some of these and they said it's probably too rare, let's just release? Or if they knew, they would have tried to patch it? And how difficult would it even be to patch these things?
So there's a lot of glitches. There's some glitches that they patched between the 1.0 release and the 1.1 and then 1.2 release. There's some glitches that they patched before the GameCube Master Quest version. There's more glitches that they patched before the 3DS remake. So Ocarina of Time 3D is actually the same code that they changed the graphics subsystem to be the 3DS version, but it's the same like code base of the game. And so there's glitches that are in Ocarina of Time that are still in Ocarina of Time 3D. They didn't leave them in there for speedrunners. They just never patched them because it's the same game code. And then there's even so like a year or so ago, maybe a little more, a 0.9 version of Ocarina of Time leaked. It was actual beta version. It was like 3 days before the final version built. So this was like the version that was like sent out to reviewers and stuff. That was not quite the final version. And that has more glitches. And there's actually like a couple of things that were fixed in that, and then they weren't, like that caused another problem. So I mean, they tried to patch whatever they could, but this was the 90s, so the quality control wasn't as strict, but also they get one chance. They publish it. There's no day one updates. There's nothing like that. So the game is decently stable and playable. It's not like the game has game breaking bugs, but not game breaking bugs that a casual player would just randomly encounter.
Yeah, I played the thing for 20 plus years, and I don't know how to execute any glitch, and I have never ran into them accidentally either. I know that
there's really easy stuff that you can do that is like useful in a casual run, and then it goes all the way up to arbitrary code execution, crazy alignment stuff that you have to do all these frame perfect things, whatever. But yeah, so that's sort of the background of this. The two other pieces I want to mention just briefly is that we have a human speedrunner save state. They do the ace setup and get the game into a state where it's then jumping to the controller input and running the controller. It's not the controllers themselves. It's some RAM which has the state of the controllers in it. And it runs that as code. And then at that point, we switch over from human speedrunner to TaskBot, which is basically a hardware replay device. I have one of them here, not the TaskBot mascot, but just the board. And it connects to the controller ports, and it just sends in button presses. Every time the console asks for the next set of, what's the next inputs, it just gives in the next one. And so normally people will make tasks like on an emulator. They just, in advance, they'll just like go through like step frame by frame and put in the optimal inputs and retry things hundreds of times and look at the memory and all of that stuff. But all of the task aspects of Triforce percent were all generated by scripts. So like we wrote code to make bootstrappers, which would then type code into memory and then execute that code and that kind of thing. And so we use this, is this combination of a human speedrunner and then TaskBot, both playing the game, both putting in controller inputs, but TaskBot is putting in controller inputs that are manipulating the console's RAM, and the human is just, playing the game like normal. And then the third aspect is that, as we've sort of alluded to already, Ocarina of Time had these pieces of beta content left on the cartridge, and then other pieces of beta content which were shown in pre-release, like videos and advertisements and things like that, then that weren't on the cartridge. And that included Link getting the Triforce, because so like if you were back in 1997, you saw ads that showed this little video of Link getting the Triforce, and then that wasn't in the game. And so everybody wanted to do that. And then there were just things that were completely urban legends that people just made up on the internet. And so we used arbitrary code execution to install a whole set of data loaders and like patches to the game engine that would let us like change the contents of the game on the fly and basically put in a new plot. And that starts with beta content and sort of gets bigger and more custom until Link gets the Triforce, and then we have this finale scene where we put in Breath of the Wild, Link and Zelda, high poly models with cell shading, and they have voice acting, they speak, and then we bring in Twitch messages live from the viewers. To actually live. I know some people in the comments, YouTube comments, are like, well, there's no way the N64 can connect to the internet. There's no way they did this. Yes, we really did it. You know, TaskBot
What
is
do you
connected to a computer.
YouTube commenters know, right?
Yeah, I mean, it's true. You can't just like plug a network cable into the N64, but it's like there's a laptop that's connected to the internet that's running connected to TaskBot, and then TaskBot's connected to the controller ports, and then we have our custom code in all of those places, and the data gets through, and you know, draw the usernames on screen. So,
is there
we made
anything
this big
special about the
finale that-
replay device? Is there something that you had to do for this run specifically, or is it a vanilla replay device?
Part of this was making custom firmware for the replay device. The first part is just a normal like task movie file that you could even just play in an emulator. But one of the things that does is then gets the game, changes the OS code that's loaded into memory by Ocarina of Time to pull the controllers 8 times per VI, per 60 frames per second, instead of 1 time, which is, normally. So we can, get 8 times the data rate going in. And, emulators don't support that. The replay device didn't support that until we did the custom firmware. And, now, are you still there? Your video just disappeared.
Yes, my camera seems to have died, but I am here, yes.
Okay. So yeah, we had to make custom firmware to make that possible. And it's actually receiving data from the computer as like more in the final data form, and then the replay device itself creates the controller inputs that represent that data, and sends those into the console. So yeah, you wanted to talk about music. I have some of the music up here. I'm not sure exactly what you wanted to talk about. Did you want to talk about like the tool chain for music, or do you want to talk about like the musical content?
Well, both. Both. Because
Okay.
many people who are joining us today here on the chat and everything, they are people who watch my channel regularly, and these are people who are interested in music production, arrangement, composition, and Reaper, because I have been working in JS Effects for 1.5 years or something like that, almost 2 years at this point. So I would love to hear about I guess there will be some limitations, things that you can play in an N64 and things that you cannot play. So you have to take that in account when arranging, and even the workflow of taking this and putting it into the console. I think that there are special tools, some tools that even you developed, right?
Yes.
Special tools that deal with this kind of thing. So I would love to hear about the process and the music aspects as well.
Yeah. Okay. So, excuse me. The process starts by, setting up a Reaper project that has, well, I guess that's not even where it starts. This is how I got involved in the whole scene in the first place. I was a music arranger. I've been doing arrangements of music from video games, not like music that goes into the video game, but fan arrangements, since like 2007 or something. And back then I was not very good. I started out just like making MIDI files and stuff for vgmusic.com. And yeah, so then at some point, somebody took a MIDI file that I had made and put it into Mario 64 and had it running in the game. But there were a lot of issues with the importing. There were like it didn't sound very good. And I started getting interested because I played Mario 64. I loved Ocarina of Time. And I started looking at like the documentation that was available for this sequence format. So it's sort of MIDI-like, but it's not MIDI. It's actually substantially more powerful than MIDI. It's sort of like a cross between MIDI and a scripting language. So it has like variables. It has registers and like control flow and calls and loops and those kinds of things. And you can do like subtraction and branching and, basic. It's a Turing complete. Well, except the fact that the total memory size is like 8 bytes. Other than that, it's like a Turing complete language. Um, so yeah, it's called, and we know now, we didn't know back in 2014 when I started on this, but it's called music macro language, which is a kind of music text-based language that existed since like the NES days. And it was even, versions of this were even used as late as Skyward Sword. So this is like a huge, long history of this, but there's like what the macros of music macro language do depend very much on the console. So like Super Nintendo music macro language, I can't even read it. It's completely different from the N64 version, but I can actually, I wasn't.
Well, I want to understand better why. I want to understand better why they needed this kind of tool. Is it because they had to compress things so much that they couldn't just, like, you have a piano roll in front of you with sort of the same notes playing over and over, and you could compress that if you had a loop? Or is it because they had some things that would react to what was happening on the screen, so they would start and stop some kind of line or part based on what the player was doing? Like you go underwater and then something else happens to the music or something?
Yes, all of the above and more.
Okay.
So it's partly for like data size and then partly for dynamic music stuff. So for example, this is Hyrule Field in Ocarina of Time. This is the program, which is Hyrule Field. It's assembly language. It's music macro language. This is like basically gonna do let's see, so load field state day, that's some immediate value here, that's 0. Store to IO register playing state, load IO register game state. If it's less than 0, branch to day next, get a random number of field day count, subtract last index. If they're equal, then get a new one, and then get another one. If it's equal, then subtract 1, and then eventually it will jump here, which will, where is it exactly? Yeah, it'll load the segment of the sequence. So Hyrule Field is like 22 different 8-measure sections that play in sort of a random order. This is the sequence this is the main Hyrule Field sequence that is loading all of those little snippets. And so it'll like.
Okay, so I guess the program isn't really doing any of. It's not generational art. It's not creating new melodies or anything like that. It's just orchestrating pieces that were composed probably in a more traditional way, probably by hand.
Yeah. So like this is maybe not the best examples to start with. Let me start with a music sequence. So this is a music sequence, and so. Yeah, both Nintendo back in the day and then now with my tool that I started in 2014 and have been continuing since then, you can convert between MIDI and this format. And initially it was between MIDI and the binary version of this format because we didn't know that there was a text version of the format. And then once the Giga Leak happened, that included all of the specifications for the text version and all of the assembler mnemonics and everything. But the community had already come up with their own mnemonics. It's a sort of a complicated, long story, but basically for like a normal music track, and this is what we did for Triforce %. You create it in a DAW, export a MIDI, put it through a program that will convert it from MIDI to the text-based version of the language, and then put it through another program. In Nintendo's case, it was another program. In our case, it's the same program that can convert in any of these, between MIDI, text-based, and binary in any of those, any direction you want, and convert it to the binary version. So like it has a header, which is really like a master track, sort of. It's like the track that is the whole sequence rather than individual channels. And then that creates independent channels, and it has like tempo commands and things, or master volume commands that are applied to the whole sequence. And in this case, what it's doing is, start the sequence, this is some mini boss sequence, whatever, changes some mute properties, initializes channels, starts these channels, master volume, tempo, waits for a certain number of ticks, then starts channels, waits for a much longer thing, and then jumps back here. So this will be the initial part, and then this is the part that gets looped.
There's something that doesn't
When it
add up
gets
to
here,
me.
it'll jump here.
There's something that
Sorry?
does not add up to me, and that is that thing we are looking at is more powerful than MIDI. So when you are converting from this into MIDI, how can you preserve this information in a way that would allow you to
Great
convert
question.
back?
We don't.
Okay.
If you convert this program sequence to MIDI, either my software will either choke on it and refuse to convert it, or it'll just be like an empty MIDI file or something like that.
Okay. So you can convert from MIDI into this losslessly, but not vice versa.
Neither direction is lossless.
Oh.
But if you have like a MIDI, if you have a music sequence that was a music sequence that was converted from MIDI, and then you convert it back to MIDI, it'll be quite close to the original. I mean, like, it's not lossless in the sense of, let's say, MIDI has a higher temporal resolution than this format. This format is locked to 48 pulses per quarter note. If you have anything that is a higher resolution in MIDI, it'll get rounded to the nearest values. So then if you convert it back, then you'll have lost information. And there's some control changes that are, well, they're not called control changes in this format, but it's effectively control changes. If you do volume or pan or things like that, there's like you can load filters, you can do, pitch bend, vibrato. There's like a separate vibrato envelope, like vibrato depth envelope and vibrato intensity envelope, or sorry, depth and frequency. Anyway, there's a lot of options that map to controllers. But like if you have a MIDI controller that doesn't map to anything and you convert it to this, it'll just get dropped and then it won't be there if you go back. So it's not really lossless in either direction, but it's good enough. So the idea is, most music, you just write it as music, you convert it to this, and then it plays in the game, and then that's that. But then you can do this fancy dynamic music stuff. And we didn't use any dynamic music, any like coding in music macro language for Triforce percent.
But how does it affect when you're composing, or maybe just arranging? Because you have to know the limitations of the medium when you are composing or arranging. So how does that change the process for you?
Yeah, so there's basically two limitations that are relevant. One is per channel, you can only have up to 4 notes on at a time. And you can only, in how many notes you can have on at a time in total is not a function of the language. It's a function of like the specific audio setup. So it can actually change like from room to room or like area to area in a game. But in Ocarina of Time, it's usually 13. So no more than 13 notes playing at the same time. And that includes like, if you have a note that has just turned off, but it has a like release cycle, like that's still playing. So that still counts against
like a voice in a synthesizer.
Notes. Yeah. If it's still in its release phase, it's still, it's still actually playing. And it has like the game's audio engine has a system that will prioritize different notes differently, and you can also adjust the priorities through commands in music macro language. So that's basically one constraint is, 4 notes, max 4 notes at a time on a channel, and then max 13 overall. And then the other set of constraints is that unlike in MIDI, where you can just like, you have your sound font, that whatever sound font is loaded, in a DAW context, you can have multiple sound fonts for different channels. But like, if you just play a MIDI file in a program, there'll be a sound font that it's using. It might have different banks or whatever, but you can just run a program change message and get any of those sounds at any time on any channel. That is not the case for this format. It's not actually a limitation of the format. It's the way that the audio engine handles banks. So basically, it only loads the metadata for the instruments that it will need for a particular song, and they're organized into banks. So let's say there's a bank that's called main orchestra, which has piccolo, oboe, clarinet, bassoon, French horn, trumpet, trombone. A complete normal set of instruments, but then it doesn't have other instruments that are used in other tracks in Ocarina of Time. And so if you want to use some instrument that's not in that bank, you have to edit the bank or make some new custom bank that will also have that instrument or whatever. And so the first step of making one of these songs is to come up with what bank you're going to use.
And are
Like,
these
decide which
samples
bank you
or
wanna use.
synthesizers?
It is sampled. So the N64 does not have any audio hardware at all. It
Huh?
doesn't have any like dedicated audio chip or whatever. It's just half done on the CPU and half done on the RSP, which is just a generic vector signal processor. And then it just, when I said it doesn't have any audio hardware, it has hardware which you give it a pointer to a buffer, and it will take the samples out of that buffer one at a time and then put them into the DAC. But that's the only hardware it has. Everything is made in software. So you could do synthesized, and actually, the Nintendo first-party audio engine, which is used in Ocarina of Time and Mario 64, does have synthesis. It has a whole chiptune engine for making synthesized audio with basic waveforms, and it can even do filters and stuff like that. But that is only used in Ocarina of Time for like sound effects that are for like the menus and stuff. So like when you hear the Zelda chime and it does, do on a square wave, that's a synthesized square wave. It's not a sample. And when you you're in the menu and you press left and it goes do 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 do, like that's also synthesized. But all of the like instrument sounds, that's a harp or a cello or whatever, those are all samples.
And typically, when people are developing games these days, they have 1.5 gigabytes for assets like images and shaders and whatnot, videos, and then they have like maybe 500 gigabytes or 500 megabytes for like audio stuff. How much data was in these samples? How much space did they occupy in the ROM?
I don't remember. Let me see if I can tell you. It's probably like 1 or 2 megabytes out of the 32 megabyte ROM.
Oh, it was generous.
Samples, but I'm not sure exactly. The sequences are much smaller, of course. Like many of our like this one, Overture of Sages. Let's see. So that is 889 bytes.
Amazing.
And the MIDI version of it is 2,371 bytes. So it's less than half the size of the MIDI. And for some of the other ones, it is even smaller. So like Staff Roll, the MIDI is 51 kilobytes, and the sequence is 14 kilobytes. So that's like a quarter of the size.
That's amazing in comparison to what people are doing these days, of course. And how did you inject any new samples or banks into?
Yes.
Nice.
So new banks, yes, for Here Together. Let me see. Yeah, there's a bank for Here Together. Let me actually pull up this info. So Triforce % run file. Yeah. So this is the file that is telling the scripts what files to inject. So there's various different types. This is like part of our tool chain for Triforce %. So this is like load a patch into the RAM patching, into the ROM patching system to patch loads to this ROM address and replace them with and apply this patch file to it. So it would inject this into RAM, into the expansion pack RAM, and then set up an entry in one of our patching systems that will have it. Whenever it loads this ROM file, it will read this patch and apply some diff to it. It's basically a binary diff to that file. And so you get down here to static data for custom music. So we have Overture of Sages sequence, Overture of Sages warp sequence, Chamber of Sages sequence, Chamber of Sages bank, so custom bank for that, Triforce sequence, Power of the Goddesses sequence, Here Together 1, 2, and 3, and then a bank for that, and then staff roll, taskbot theme, and trailer theme. So yeah, 2 custom banks for Here Together and for Chamber of Sages, and then all of this custom sequences. And then as far as samples, yes, all of the Link voice acting, Zelda voice acting, chimes as Zelda comes down, and then Breath of the Wild Link's footstep sounds are the Breath of the Wild footstep sounds for the respective types of surfaces. So Ocarina of Time has like 13 different types of surfaces that have different footstep sounds, but Breath of the Wild has like dozens of them. And they all have like different versions for how fast he's moving and all of this stuff. So we picked out just a few of them, and he steps on stone and grass, and then his belt pouch rustles. So yes, these are all custom samples that we injected too.
The attention to detail is amazing.
Samples, sorry?
The attention to detail is amazing.
It's thanks. It would be it would sort of feel weird if you had Breath of the Wild walking, but it was Ocarina of Time Link's footsteps. So yeah, the voice acting samples. This is 1/3 of the payload. Was the voice acting samples, and then the other samples of all the data we injected, like 1.2 megabytes or so, and that was 1/3 of it, and another 1/3 of it was the Breath of the Wild Link and Zelda, models and animations, and then everything else. Custom scenes, music, actors, everything else was another 1/3 of that.
So this file that we are looking at is like the manifest of everything that was injected.
This is like the 3rd step. So the 2nd step is here. This is like the first step is we run a task movie. It gets us from 1 instruction per frame to completely custom code, polling the controllers 8 times per frame and listening for further instructions. Then there are these ones that are these are linked to static addresses in memory, and so they have to be injected in the same place every time. And when we inject them, there can't be any mistakes because it will execute them as soon as they're injected. So if there is any mistakes or whatever, it would just crash then. So we run this as a separate thing, and this is a debugger. The DMA patching system. So basically, when the game goes to load something from the cartridge, then our code will look at it, check a list of addresses. Is this something that we want to change? And then before it returns the data to the code that requests it, it will patch in whatever we wanted. So that's this system. And then statics is all of the other statically linked data. This is like all of our text, custom text, all of our changes to different aspects of the engine, changes to Ocarina system, changes to interface. We can go over all of that in the second half when we're talking about
but hang on.
stuff.
Are you telling me that there was a chance that you would start the injection and it would fail?
Yeah, but not a good chance.
Okay.
So if we, so one of the interesting parts of this is like, when you're doing any data transfer that is like a large amount of data, you need that to be bidirectional. There needs to be some way to have the recipient tell the source, was this correct or not? But we were limited to we could do whatever we wanted once we had the custom code running on this. One thought would be to have the taskbot or the replay device pretend to be a memory pack, and then you can just do arbitrary 32-byte reads and writes from the console. But the problem is that is not theoretically human possible, because the idea of taskbot is that it's all things that a human could do, just like way faster than a human could do it. But all of the button presses that we made for Triforce Percent, a human can't do them all fast enough, but if you slow it down by thousands of times, then a human theoretically could do it. So in order to keep that up, instead we had the replay device pretend to insert rumble packs into virtual controllers 2, 3, and 4, and we have the console turn on and off 3 rumble motors to encode a 3-bit value, and then that tells the system on the computer whether the data. So the console.
It's the acknowledgement from the N64
right.
back to taskbot.
Yeah, so it checks a CRC. If there was a mistake, it sends back, and then it resends the data. And the thing is that when you go through a loading zone or you pause, basically if you stop normal gameplay, some of the packets will get lost. And then the problem is that normally, if that happens, we will find that out by looking at the Rumble results, and then you'll just resend things later. And there's no problem. He just wrote it. It was wrong first, and then it rewrites over the same data, and it'll be right. And as long as we don't use it in the meantime, then that's fine. But the thing is, for the statically linked stuff, if it's wrong, it gets used immediately. So if there was something that was missing and there is some set of that code that was all zeros, it's just going to probably crash immediately at that point. So we had to do that as a separate piece and not pause, not go through any loading zones during that time while that little section was injected. And so if you rewatch the video, you'll see we have the first section, we have taskbot and Link wiggles around or whatever. You see a little green bar in the corner. That's the end of the first section. Dwango then types something on the laptop and it runs the second part as I'm saying, oh yeah, now we have to just go over to this house. And, or I was saying like, oh, that was the big moment. You should have clapped for us, whatever. And while that's happening, we're doing the second part. We're just like stalling for a few seconds. And then you see Dwango gives a thumbs up to save state. And then save state goes into a house. And then we've started the third one. And the third one, it can fail, it can do whatever, it'll just keep going. In fact, with the third one, once that's all set up, you can even kill Link, go back to the title screen, start a new file, it'll still just keep injecting stuff while that's happening. So we got a bit off on a tangent from the music format.
Yes, I think it will go like that, because we are all interested in both aspects of the run. So, okay, so you're telling me that the chance was small, but it was there. It could have happened. Amazing.
Yeah. So, and actually, there was another thing we didn't find out until later. There was a bug in our code for melting the ice in the Zora's domain. The operating time has an environment system called Kankyo, which one of the things it does is snowflakes in a cold area. There's like snowflakes that drift down the screen, and we faded out the snowflakes by like changing the count of snowflakes per frame from like 16 down to 0. But the original game code made an assumption that there would always be a multiple of 2 snowflakes. And my code for fading out the snowflakes just counted down directly from 16 to 0. And the problem was if my code counted from 2 to 1, and then in the same frame, the game code counted from 1 down by 2, it would underflow to 255 snowflakes. And then the matrices for the snowflake positions would start getting read out of bounds. And some of those snowflake positions would then be, not floating point numbers. They would be not a number. And then the game code for converting matrices from float to short for the rendering hardware sees that it's an invalid float and crashes. Like it's crashing on purpose to tell the developer that there is a mistake here, so you can actually look at the stack trace and like see where the problem is. And the chances of that happening with the two like fading out the snowflakes happening at the same time was 1 in 16. So there was 1 in 16 chance that when we melt the ice in Zora's domain, it crashes. And it only happened once when we were testing. It happened once in like March, and we couldn't get it to happen again. And at that time, we had some issues with the crash debugger. After that happened, I like patched some other things with the crash debugger so we could actually get the crash dumps. But it only happened once. We had no idea why. We tried to replicate it. We tried a bunch of different things. Couldn't happen. We just did the run live and it worked. And then Dwango was setting up for another run later and it crashed again. But since we had made further changes to the crash debugger, we were able to get screenshots of the stack trace. And I was able to figure out from the stack trace where it had called its way through and saw that it was in like snowflake code. And I was like, oh shoot, I messed with that code. I guess I actually made a mistake. And then I found this. So
when the hacker
there was a
becomes
1 in 16
hacked,
chance that it could have crashed live at GDQ. Sorry?
When the hacker becomes hacked because you were playing around with someone else's code and you were able to do that because of a bug, now your code has a bug too. Fun stuff.
Yes.
You know what could have been fun? Instead of using the Rumble pack, you could have given some visual feedback and had a camera on Taskbot. That would have been fun.
Yeah, so we haven't. So Taskbot has Taskbot is like a community, right? It's not just like there's the mascot, and then there's a community. So I think they used not visual feedback, but like analysis of the HDMI signal to do the Super Mario Maker 2 tasks. They actually have to like synchronize to VSync on the HDMI signal. And then in a future upcoming project for next summer, they are using like a different kind of feedback. They basically, well, I don't want to spoil too much, but it's responding to what's happening in the game. Normally, TaskBot is never responding to the game. It's just feed in, next controller input, next controller input, next controller. That's it. But the one they're doing next year is also responding to what's in game, and in fact has a human player, and TaskBot will be playing against the human player. But it's also not doing that through looking at the video signal. It's still a difficult problem with like AI research to make an AI that will like watch a game and like figure out what to do. So it's through some like memory stuff that it's being able to get information about what is going on in the console's memory out from the game in real time. But I won't go into more detail.
Fair enough.
Fotis and stuff asked, did you use the Breath of the Wild sounds from the Wii U version or the Switch version? The latter sounded better. I was not the person who extracted the sounds from the Breath of the Wild ROM, so I don't actually know which version they used, but the Ocarina of Time runs at 32 kilohertz audio anyway, so bringing in 48 kilohertz assets would not have improved the output at all.
Yeah, well, actually, can you explain to us briefly how is the process of going from a WAV file into some of these .bin files that you loaded? I mean, the samples were .bin files. How do you get them?
Yeah, so I can give a brief overview, but it's 80 PCM, so that's like a standard format. It's an adaptive delta pulse code modulation, so it has a filter. It takes the previous 8 samples, puts it through an FIR filter, predicts the next sample, and then encodes the difference between that and the real sample. And it's like 4 bits per sample encoding plus some metadata and stuff. I didn't write that. Somebody else wrote the tool for converting it. So I just, run it through the tool. And so for each file, there's the bin of the actual sample contents, but then there's also a predictor, like filter dictionary, and also some loop information. So there's some metadata as well as the actual sample, like list of values for every sample.
And do they do that as a compression mechanism?
Yeah. Yeah, it's like roughly 4 times less dense than WAV files.
Fair enough.
4 times denser, 4 times smaller size.
Okay, so what you have in front of you is a Reaper session, and these are MIDI items. And in these MIDI items, I guess they're going to play back some kind of sampler, and you loaded the samples that came from the N64 so that you can work with this in Reaper and produce the thing that is going to be loaded that we saw before, right?
Yeah, it's, somebody wrote a program that will export the samples as DLS sound fonts, which is sort of like SF2, but it's a different format. And then this Plog Sforzando is a free plugin that will load DLS sound fonts, and then you just map. Some of them have like interesting mappings where like they will have different split points. So like this is a different sample, and this is a different sample, and this is a different sample. But that is embedded in the DLS sound font. Back when I was like first doing this in like 2014 or whatever, that didn't exist. So you just get WAV files for each of the samples and then just load them up in a sampler and have to put in the split points manually, and then match them to but the split points and stuff is in the bank. So when I mentioned like this is why you have the different banks, it's the split points, volumes, the pitch. Actually, I don't think there's volume in there, but then there's the filter and the like the predictor for the ADPCM and some loop information for the ADPCM. It has to know like when it gets to the end and then goes back to the beginning, the last 8 samples aren't the same as the previous 8 samples when it first started. And if it puts those in, it will diverge once it starts redoing the loop. So it has some like filter state that it puts back in when it does the loop. But anyway, that's like really detailed part of the format.
That's
That's
fascinating
not
to me.
something I had to directly deal with.
But there is something much more trivial that stands out to me. It may sound silly to you, but having heard these sounds for 20 plus years, it feels like magic when you're playing them in a sampler like this. It's so crazy to hear these sounds that I know so well, and you can just play with them. That's like magic.
Yeah, so like I have another Reaper session I won't load right now that I have like mapped a whole bunch of Ocarina of Time like sounds to the different manuals of my organ here. And so I can just like play Ocarina of Time strings and harp and ocarina and stuff just for noodling around. So that's always fun.
Is this something that is available to the general public, or is it like copyright?
The Reaper session?
No, I mean this kinds of sound banks and samples.
Well, I mean the individual sounds are copyrighted, but you can find them perfectly easily online. You can find. In fact, somebody has packaged the 3DS used a different like bank format that was reverse engineered sooner, and so there's a pretty old just SF2 sound font of the Ocarina of Time 3DS samples, and so and they used like the same underlying AIFC files or it was AIFF and then AIFC was compressed version. So the underlying AIFF files were used in the 3DS version. And then also a lot of them were in the GigaLeak. So we just have the original samples that Nintendo compressed originally. Of course, the GigaLeak is, not theoretically you're not supposed to access that, but if you wanted to, you can find it online.
That's all we need to say about this.
Yeah. But yeah, the sound fonts, you can find all of this stuff. There's, most people who make like, Steve Gunner, for example, makes music with N64 sound fonts. Nobody's actually making it and injecting it into the game except for me. I'm the only person who, maybe a couple of people occasionally do this, but most of the time people just make stuff in a DAW and then, export it. It sounds good enough. You can actually hear the difference between the 48 kilohertz and the 32 kilohertz. You can actually hear whether it was actually recorded from hardware or not. This sounds, has a fuller high end or a brighter high end than it would on the console. So Fotis and stuff says, oh yeah, Siva Gunner. So, Siva Gunner was our publisher for the OST. We made all of these tracks and, then, recorded them from the game, actually save state and taskbot, we save state did the exploit. So the actual tracks that are up on Siva Gunner are actually recordings from an unmodified cartridge that had the data injected, the real N64. So it's real high quality rips of Ocarina of Time. So that's part of this. But so you want to talk about some of the like specific songs, because there's a lot I can go over with them.
Yeah, let's dive into one of them and perhaps go through the song and show the different parts, play the stems.
Yeah, so I mean, this one is not necessarily the one we were going to go through individual parts, and there's a couple other ones that are more interesting for that stuff. But this is the Overture of Sages. I did not compose this song. Ariana Almendoz, the infamous hoaxer back in 1999, composed this song. It's in a screenshot saying this is the Overture of Sages. It's D F A D F D A B D, right? So C up, C down, A, C right, C left, up, C up. So like I took those notes. There was no rhythm to them in the original hoax. It was just those 6 notes. So I came up with a rhythm, came up with the chords, and then arranged the background sound. So this is the like learn song demo cutscene. And of course the ending part of it is that's Power of the Gods from A Link to the Past, which is the theme that plays in the Triforce chamber after you get the Triforce. So
The attention to detail.
EE33 said the ones he's talking about are more manually made versions. I think you mean about the sound fonts. Yeah, you can just like download sound fonts that are sufficient for DAW use. From you can Google things. Yeah, so let me open. I'll sort of quickly go through a lot of the music, but then spend more time on some of them. So then there's the warp version. So when you warp to the Sacred Realm, it starts off as the same song and then it changes. And of course, that's the Master Sword theme, because this is occurring right in front of the Master Sword as you play the song, and then the camera goes up into the Sacred Realm. Fotis and stuff says there are even crazier people who try to find the original hardware sample libraries used by composers. Yes, so that has been done, at least to some extent with this. Nintendo just licensed Roland samples, so you just like buy the old Roland samplers and you'll just get the same samples that they use. In fact, there's a spreadsheet that is like one of the resources for creating Siva Gunner mixes that has like thousands of games and individual samples, and they say like this sample in this game is Roland whatever Juno, it's this patch on this instrument, and then like you can actually use it yourself. Did you have
crazy,
anything
right?
to say about these?
It almost feels like there were people working on this. It wasn't just a piece of magic from our childhood. There were people working on this using tools and programming. It's crazy.
And that's the funny part, especially like with the whole like connection to Ocarina of Time that this all represents for me and for so many other people. It was always like, this game is full of magic, and how could all of these things be possible? And you would think that like once you get into the code, because we based a lot of this is all based on the decomp, not based on in terms of the like tool chain is totally different, but we looked at the decomp all the time in order to figure out like how is the game working, right? Because look at the source code, and going through the music or whatever, you would think that it would like lose its charm. It would like, you see behind the curtain, you see how the magic was done, then it's like, oh, that's all it is. But that hasn't happened for me. Like every time the rabbit hole always goes deeper, it seems. There's always another thing, like once find out how flexible this whole chiptune system was in the with the MIDIs, that like there's unused sound, there's unused wave types that haven't been used. There's an unused noise type. So chiptunes, you have sine wave, square wave, whatever, you have noise. The way they do the noise is by having the 80 PCM as a pointer to the function that's parsing the noise. So it's parsing the MIPS code as 80 PCM data and just ships that off as like, okay, there's your noise. But I've tried it. First of all, it doesn't sound like white noise. It sounds terrible. It sounds like a dial-up connection kind of sound.
I know
it's not random.
Sorry, I know exactly what you're talking about, because we have been working on this for a couple weeks, and yesterday I started a tool that does exactly that, data bending. In our case, we are doing this for video, and we are taking a stream of bytes that make up a video file and processing those bytes with audio effects, and vice versa. But it's fascinating that they were doing this as well. And I know exactly what it sounds like, because we have played around with taking a video and hearing it, or taking a song and looking at it.
Yeah, so it doesn't sound like the kind of noise you want for like chiptune noise. And then also there's a bug in it, and like every like 30 or so seconds, it just hangs the RSP, because like something with the way that it's like trying to load from memory. I'm not exactly sure what the bug is, but if you play noise, it'll just occasionally hang. And that's interesting. I didn't know that Ocarina of Time had that. So yeah, there's so many things I've been working on recently with like optimizing display lists for the RDP. I found out from looking at the leaked Verilog source code for the RCP, which was in the GigaLeak. It was actually before the GigaLeak. It leaked many years ago. But you can just look at the Verilog source code for the chip, and I found out that most of the sync commands are like useless. And the way that the official GBI handles syncing is basically just useless, like wrong. Like you do need some of them in some cases, but it's just like does too many of them and it just needlessly stalls. And there's like there's always more to discover and find out of like, oh, and it's all connected also. Like the reason that the game will run at a particular frame rate is because of how long it takes to do these particular transactions between frame buffer temporary memory and the RAM bus RDRAM, and that particular transaction is what defines the whole console in a way that like people don't even realize. So anyway, there's so much that you can get into. So yeah, it hasn't lost its charm. It hasn't lost the magic, even though Nintendo just, I mean, we know that they made the soundtrack in Cubase. They used Cubase. They just exported MIDI files, and then they bought these Roland sounds, and Koji Kondo went and bought these like other sample CDs, and that's how the Fire Temple had Muslim chanting and stuff. Is he just like got these sample CDs and like, oh, this one sounds cool, and then uses it in the track. Yeah, shall we get into some of the more elaborate music?
Yeah, let's do it.
So I want to talk about, let's see, should I start here? I sort of had a thought ahead of time of what order I wanted to do these, but now I'm kind of thinking about doing it in a different order. So let's talk about Here Together. So this is the music for the big finale with Breath of the Wild, Link and Zelda, and Twitch messages and everything. And so this is a more complicated. Well, it's a larger bank. This was custom because I needed these bells. This is used in like the ending of the staff roll for Ocarina of Time, and I wanted to use it in the ending of now our custom thing. Sounds like this. It's the same bell that's used in Majora's Mask for Clock Tower also. So that's why it's a custom bank, but you see other audio here. This is because I had to actually like produce this cutscene, and for the cutscene, I needed to get like character animations and camera motions and music and the voice acting to all be synchronized. And this is normally, maybe you would do this in like a single production program. You have like Maya, and you do the animation in Maya, you do the camera motions or whatever in the same program. But here it's like Blender, one scene for the cutscene, another scene for the characters. So I decided to like do the timing of all of this in Reaper and export this narration. So this is never intended to be heard by the public.
Yeah, I was going to ask you that.
Camera pulls back.
I was going to ask
So this
you
is me speaking.
Is this Reaper project part of the thing you can find on GitHub?
So no, we have stripped out anything that isn't like actually goes into the build. So like the Reaper projects are not in the release, but the MIDI files and the sequence files are.
Okay, I assume the same is true of the Blender projects.
To some extent, I forget. I think we left some of the Blender stuff in there. Yeah, it was mainly just of like trying to make sure that there weren't like, like this project has my real name in the data of it, and so like I don't want that to be up online somewhere. Though it's unlikely people will pull open this Reaper project in a text editor and try to find things, but just trying to have a clean release. So like this has my voice narrating what's going to happen in the cutscene. On the Triforce chest, camera pulls back to slowly reveal that this is a different scene from where we just were. Second establishing shot of the island in the Sacred Realm. So so I made that and then like composed along with this. So we have like, this is when Zelda starts descending. And then we have the Zelda voice line. So this is actually like early pre-production Zelda voice lines in this project.
Link, it seems you've managed to bring together a great number of people. I'm so happy to see this.
It's not the same version that is in the final version. And then...
And it's crazy that this media item we were looking at was a third of the payload or about something around that.
The voice acting, all of everything that Zelda says and everything Link says. Yeah.
Amazing. I mean, look at those media items. It's almost like almost nothing.
Well, they're not MIDI items. They're WAV files. But then even that, this is
I didn't say MIDI.
File, so
I said media.
Oh, mini. Sorry.
Media files.
Oh, media. Sorry.
Yeah, because the media items is how Reaper calls these little boxes.
Right. Sorry, I was just mishearing. I thought you were saying MIDI because in your accent, MIDI is meaty.
Yeah.
And media. Anyway, sorry. So some interesting things to show here. So I'll play through for like the main section here. I'll play through the main section, the way it is in the final version. And then I will talk about a few of the pieces of it. So this is like part 2. These get exported as 3 separate MIDI files because there's going to be like a pause at each of them, and we want to realign everything in time.
Look!
So this is while the Twitch messages are on screen.
You asked to see our future. Here it is. For all you have done for us. Thank you, Link. For all you have done for us.
And we have Link here.
ゼルダ姫、ありがとう。一緒に未来を作りましょうか。
So a few things. First of all, this is an elongated version. The original version was shorter, and then even before that, so you can see there's more stuff here past the end. Previously unseen beta versions of the music. So this went through a lot of, iterations and everything. And so I thought, are you interested in hearing some about this?
Of course.
Okay. So it started here. I won't get into too much detail. We'll talk about this eventually in some point in the future, but there was an earlier concept for what would happen at the end, which I probably still shouldn't talk about. But it was going to be a different concept, and it was going to be like less bombastic. And there was no Twitch messages, no Breath of the Wild characters. And so, but still sort of like a meaningful completion to things. So this was like I was, starting to compose or, arrange, because these, this is all based on themes from the Zelda series, as I'll also go through. So I shouldn't say compose, because it's not like original. But this was the first version of this, as I had these two little snippets that I wanted to be part of this. So this is the first one. So a couple of things. First of all, you'll notice that I'm using a harp for the low piano note, because the low piano just sounds like, oh, wrong channel here. This is 16. It's not very, it's kind of jarring, right? So that's why we're using the harp. Then also, of course, so this is, so that's the B section of Zelda's Lullaby, and then this is the Twilight Princess theme. And that became this. Make sure I find the right point here. I think it's here. And then there's a second little snippet here. And that became so a couple more notes on the themes here. So in between those two, in between those two versions, I was trying to, so I was, the idea here is that I'm trying to pack as many different themes from the Zelda series as possible into a short amount of time, because this is like the soundtrack for Here Together. It's bringing people together. It's bringing all of the different themes together. So overall, there's these three themes that are the theme of this song, and one of them is actually the theme of Triforce Percent, which I'll talk about in a moment. Some of this was, we were hoping to do some video or some talk about this, but I guess I'll spoil some of this now. Eventually we can still do a video, of course. I'm sure people won't, not a lot of people have seen seen this live stream, but that's all right. In between, I'll talk about the themes in a minute, but I want to first show a different version. So I was like, okay, well, I got, Twilight Princess and I got Skyward Sword, though that was actually a later edition. I was like, okay, I got to do Wind Waker. And I was also trying to get the Zelda theme and the Zelda's theme and Link's theme to be more directly together all the time. So this was then the first version of the more bombastic Here Together version of this. So, a little less fleshed out, but we have Link's theme, which is the Zelda theme. We have the Wind Waker theme. And then we have Zelda's Lullaby. And so this little chord progression, then I ditched this beginning because I wasn't satisfied with it. This chord progression stayed, however. And so then it became this, and I'm going to sort of skip around because this is the final version is the most elaborated version, but I had taken out a little chunk and then put in a bigger chunk there. So this is what it then originally, what it sounded like after that.
future. Here it is.
And then the next part would be here. So I sort of extended things. Dwango said, we had a first version of this. Dwango said there wasn't enough time for people to have Twitch messages on screen, so I had to compose, arrange more music to make it longer. So let's talk about all the themes here. So there is, this is all about uniting Zelda's theme, Link's theme, and the Legend of Zelda ending theme. So there is this kind of hidden motif, which is just a G major chord and then an F major chord. And that is the Zelda ending theme. It actually originated from Star Fox 64. It was this 2-chord progression was used as like the end of the ending, written by Koji Kondo. The ending of the end credits for Star Fox 64 had these 2 chords. And then Koji Kondo put it in the ending of Ocarina of Time. So it's the like when Link just puts the Master Sword back, or he comes in after the Master Sword, the camera turns around, it shows the Nintendo logo. It's that chords. I don't have it. I don't think I have a version of this set up that I can play right off the top of my head, but it's right on stream right now. But it's those same 2 chords, and then the ending for Majora's Mask is also those same 2 chords over an F in the bass instead of over a G, but it's still the G major, F major. And what those sound like, it's these chords. So then it was in Breath of the Wild. The theme for I can pull this one in. I can pull this one in, and it'll just take me a second. Sorry, 1 second. Demo BGM. I think it's this one. So this is when the Divine Beasts fire their lasers at Hyrule Castle. It's the same. Now it's in E flat major, but it's E flat and then D flat. And I didn't realize that this was the same just from having seen this scene. But then in the ending for the DLC for Breath of the Wild, they use the same theme, but it's transposed to be in G major again. And so it's the same G, F, G, F, but it goes on and does the Champions, version of it. So it's used in those 3, main Zelda games. I don't think it's in Twilight Princess or Skyward Sword ending. But it's used as like part of the ending theme for all of those. And then on top of that, there is a fan mod called The Legend of Zelda: The Missing Link, which I did the end credits music for. And it happens between Ocarina of Time and Majora's Mask. And so I based the beginning and end of that end credits theme on the same GF chords. So that chord progression was then like instrumental, no pun intended, to Triforce Percent. That's sort of like the theme of Triforce Percent. And in fact, it is also used in the Triforce Percent trailer, which was released, publicly released after Triforce Percent happened, of course. And this is, this is a video project. I gotta not have my screen taken up by this, but mute. So it's a trailer like describing like this is on YouTube on my YouTube channel, but it's like describing what would you do with arbitrary code execution? Would you make ultimately would you make people's dreams come true? That's the idea of the trailer, and it ends with. So now in E flat, but it's E flat, D flat chord. So that's where it starts for Triforce %. That's where the theme first starts. And then it is, used here together. So, because this is, the idea is this is the sort of with very big quotes around this, because this is our concept as fans, but it's sort of the true ending of Ocarina of Time in the sense of getting the Triforce and then creating the future. And I don't want to be like vain in saying like I created the true ending. Like this, this is just a fan concept, but the whole idea of getting the Triforce and this being actually on the real unmodified copy of the game just by pressing buttons, that was the emotional idea here. So this is, the Zelda ending that we all wanted. So that theme is used throughout, and all of this is a combination of that theme with other Zelda themes. So starting off here, we have. If I start, so you wanted to hear some stems?
Yeah.
So let's play some stems.
What's up with those media items in the beginning of every section? You have a bunch of media items. Very small
you mean
ones.
Here?
Yeah.
These ones? So these are sorry, what's going on? What do I have soloed? I have these soloed. These are setting up like the initial state of the this is like the program change, the initial volume, the pan, that kind of thing.
I imagine, yeah. It's the kind of setup that we will end up in that code that we saw, right?
Yeah. So like I export a MIDI like starting from here, and then that is the beginning of it, and it it sets that up. Mm-hmm. So that's just part of what you got to do for the N64. So yeah, we have. So I can leave this one. So this is Zelda's Lullaby, of course. And then if we do the other stems, it's the Zelda ending motif. And that's Zelda's Lullaby again. Then we have here, this 8-bar phrase is a different combination. So this is...
Everyone loves a good mashup.
Yeah, I mean, that's kind of what I've been doing music. That's kind of my musical taste, is like taking things that are emotionally meaningful and then like play them at the same time, but not in like a weird way, like in a, to make it, beautiful and it's a true form kind of way. So more Zelda's Lullaby, but now the other theme is Link's theme. Which you might know as the Zelda theme, but in Skyward Sword it was very clearly established canonically that that is Link's theme specifically. So of course, this is Link and Zelda on screen and connecting to everybody. Then we have this little thing is not really, I don't think this is really anything.
Future has to see our future.
Whoops.
Here it is.
I unmuted too many things. don't think that's really anything. We have B section of Zelda's Lullaby here with a custom horn counter melody. I feel like I've heard this before somewhere, but I'm not exactly sure where. Then we have the like Twilight Princess sad theme, or like main theme, but not the Hyrule Field theme. Then we have the beginning of Rito Village from Breath of the Wild, which was original. I was originally thinking that this would be Dragon Roost Island, but then like the part that would be like the Wind Waker representation. But the part of this that I used is actually the part that's in Rito Village that is not in Dragon Roost Island. So, oh well. No Wind Waker representation. So like that one. Then we have the Majora's Mask representation. Song of Healing.
The attention to detail. I didn't catch most of this when I was listening to it.
Well, when it's on stream, it's live. It's supposed to be just like going into your brain and making you feel, emotionally positive things. This is, this is designed to make people cry.
To me, it sounds like to me it sounds like you are making people remember things that they are hearing for the first time.
Well, yeah. I mean, that's the idea. That's the whole project is like, you always knew about this and you sort of wanted it to be real, but you didn't really know. Like it's sort of that space of you recognize this, but you wanted it, but you didn't really know if it was real, and then it sort of wasn't real, but then now it's real, and so then the same thing with the music. So we have our Skyward Sword representation now. And then this is Link's theme again, but this is actually the version from the end of the Twilight Princess theme. This is the same song from Twilight Princess as this one. This is the GF again, the Zelda ending.
Zelda hime, arigatou.
And so this part, there were a few versions for the music while Link is speaking. So the final version is this.
一緒に未来を作りましょうか.
Then an older version was this, and I actually like this version. I'm sorry that this didn't end up going in, but... and then there was also this version. Same idea, same chords, but just a different arranging. And then for the fanfare from the horns here, I originally had it composed as this. And then I realized, oh, wait a minute. That's one note away from another very important theme to be playing here. So that is the Breath of the Wild theme. So this is, Breath of the Wild, Link talks, and then it plays the Breath of the Wild theme. So, and then finally the Zelda ending theme again. And the next is Staff Roll. So this is pretty straightforward. I actually did this arrangement with some caveats. This is, I did all of the arrangements except for the Chamber of Sages arrangement, which was made by Rebecca Tripp. But what I was trying to say is, this is Ocarina of Time 3D Staff Roll 2. This is the extra staff roll for the remake, which was in the 3DS version, which is played by a live orchestra in that version. There's one other thing I'll mention about it in a moment, but I had done this arrangement of that piece for the Ocarina of Time engine for Siva Gunner back in like 2017. So I already had most of this done. It has like a different intro and everything, but this was mostly done. But this version is faster. I've improved some things, added some more timpani, sort of beefed up the arranging a little bit, and then added a new intro and a new ending. So the intro is Link's theme again, but this is the version from Age of Calamity. This is the one where right after Link, like immediately after Link picks up the Master Sword and awakens his power, you get this version. And then, of course, this is the beginning of the Hyrule Field theme. So, Staff Roll 2 from Ocarina of Time 3D is mostly this arrangement of Hyrule Field, but then it has some changes. So after the slow section with the oboe solo, then the next thing is, and this is the other reason I chose to include this, is it is the Zelda theme. Link's theme again, but it's the Zelda theme, the original version. This is the first time that it is in Ocarina of Time, because the Zelda theme, there's a short version of it in Hyrule Field, but it's not the whole thing. And so, that was the original part of the original joke with the Siva Gunner version, was that, okay, now it's in the game, but now it's really in the game because this is really, unmodified cartridge. So, So, of course, Nintendo made that choice to finally put the Zelda theme in Ocarina of Time for Staff Roll 2 for Ocarina of Time 3D. That was their artistic choice. So we just put it in the original game. And then, this is another idea I had for the intro. But I decided to go with the other one. This is I was just messing around with this. So this is a arrangement that I had done back in 2008 for VGmusic.com. That was like a combining different, it was like bring a medley of music from different Zelda games. And this was the very end of it, which was originally based on the ending of the Twilight Princess staff roll. And then I added the Triforce theme to it back in 2008. And so I tried arranging that. I was like, maybe there's some way I could work that arrangement that I had made so many years ago back into this. But there's just not enough voices in the N64 version. So this is using all 13 voices. And it's not dense enough because there's 4 different melodies happening at the same time. And there's just not enough voices to make it sound good. So.
I don't know what you're talking about. It sounds good.
It's too empty in the middle. There's not enough inner voices. As the arranger, I was not satisfied with this, so that was not used. And it's also at a different tempo, and it's a little bit. So this is the original way that the track ends. So it goes up into B flat major now. It was in G major the rest of the time. So that's the item get theme. So that was how the track ended for the 3DS version. But I was like, well, no, I gotta. First of all, I don't like it changing from G to B flat because Triforce percent is in G major in the sense that like a lot of everything from here together to the end was all in G major. So like, why would you then just U-turn at the end and end somewhere else harmonically? And Hyrule Field is in G major, and Zelda's Lullaby is in G major. So like the game is in G major in not all of the tracks, of course, but like in some sense it is. So I wanted to end it in G major, so I had to change how this modulation happened to end up staying in the same key. But then, of course, I wanted to go back to the common motif here. So this is what I do instead. And so then we have two different themes again, playing at the same time. Which is the start of the overworld theme from Zelda 1. And then, of course, at the same time, we have the Zelda ending motif.
Mm-hmm, mm-hmm.
And so together,
Lovely.
So, do you have any comments? There's some other music that I didn't touch on. There's the Chamber of Sages by Rebecca Tripp, and there is Power of the Goddesses by me. There's the rest of the trailer. But what do you want to do now?
Well, I am interested in knowing how the pieces are put together, because you were composing this with a narration of what was happening, and then at some point you were loading the animations and the code and everything and test it out. Was it the case that everything just fell into place first time, or did you have to iterate many times until you got all the things to fall in place?
A decent amount of iteration. So one of the things that I did when I was starting Triforce Percent, was I contributed to this Blender plugin called Fast64. And I also made a separate plugin that was just for camera motions in cutscenes. And then I added the rest of the cutscene commands to Fast64. It's kind of a long story of why it happened that way. But basically, I created cutscene editing tools for Ocarina of Time in the community software. There was an existing program that was Windows only that had a cutscene editor, and it was difficult to use, and it did not have a previewer. So you could create the keyframes for the cutscene, but then you couldn't actually see how it looked without saving the ROM and then opening it up in an emulator or on the console or whatever, and then trying it. So the Blender version that I made had a previewer, and it used the actual algorithm from the game. So you can actually just press play in Blender and watch the camera fly around and how it will be in game. So that was, essential to making any of this be possible without way more headache and frustration. But then even with that, there were a lot of, because this is this is effectively directing a movie of getting all of the the character actions, and there are other actions of things that will happen at specific times for the lighting and stuff like that, and even what frame Link starts walking on will then change. So there's a lot of things to get set up in the cutscene, and then there's the music, and then all the other aspects like Twitch messages. So yeah, I would say probably 50 to 100 times I ran that final, iterations of running that final scene in the game and trying it. Actually, an interesting thing. So I don't know if we're going to have time, because I'm not sure when you're ending today, but we could show some of the code stuff. One of the interesting parts of this, since this is all code injection, you don't need to build a ROM and then start the ROM and then go to where you're going. You can have Link, in the scene, edit the scene, export, build, inject while the game is playing, have Link jump off a cliff and die and reload the scene, and it'll be the new version of the scene. And it's actually faster to iterate with code injection than to iterate using an emulator and like save a ROM and reload the ROM and then get through the menus and then get into the location. So like with the working on Breath of the Wild, Link himself, that was like just make changes in Blender, hit export, while the game is running, re-inject, jump off the edge, reload, and look at it. And there was a ton of iterating on the physics, because the hair and tunic and like for Link and the hair and dress for Zelda are computed live. They're actual physics simulations with like double pendulums for his hair. So there's like two pieces because it can like swing like this way, but then, well, anyway, you get the idea.
Yes.
So yeah, that was all simulated live. So all the parameters for the simulation of like the forces and the accelerations and stuff, there was like a lot of iteration on that. Because if it's wrong, then the hair just like flails all over the place or whatever.
Yeah, I asked that because I remember seeing you saying that there was this one place where Link holds an item and you had to spend 5 hours to make the item look right, to put it in the right location.
Oh, yeah. Yeah, that was just like...
and
so
I can only imagine how long it would
Link.
take to sync all these other aspects. If one item in one scene takes that much work.
I mean, that taking 5 hours, that was not like... That was sort of an exception. That should have been faster, but it was like there was somewhere in the original game source code that was causing this wrong behavior, and I didn't know where it was, and I needed to find it in order to be able to fix it. And, then I thought I would just sort of went down a wrong path or whatever. That's why that took 5 hours. But I don't know how long would I say this finale took. I mean, I don't even know. Probably 200 hours to make the ending, the cutscene with Breath of the Wild, Link and Zelda and everything. From the music arranging, doing some of the Link animation, cutscene cinematography, coding the Twitch messages actor, which it's actually rendering the text in game. It's not like somebody said in the YouTube comments, oh, it would have been too much work or whatever to have the text rendering done on the N64, so they must have just injected the textures. On the contrary, we don't have enough bandwidth to inject textures in enough speed to do the messages. So we have to compress the usernames into like it's only 6 bits per character because that's all we can afford, and then put them in and then have the text rendering done on the console because it would be impossible to do it the other way. So getting all that to work with all the, because it supports all the not all but like a couple of dozen badges and a couple of dozen emotes and an arbitrary number of exclamation points after your message here together. And like all of this stuff, and it had to render. It's not even fully correct if you render things in the wrong order. So there's some weird transparency issues and stuff. But yeah, a lot of work. This is a labor of love, of course. Easily 1,000 hours on the project, besides tools development, which is like what I do in my free time is N64 tools development.
But if you factor in that it raised $250,000. It's a pretty good deal, actually. It's not that bad.
Yeah, but I Dwango does this partly for the charity impact. I didn't really do it as much for the charity impact as for the emotional impact on viewers. I wanted to get the Triforce. I wanted the world to have gotten the Triforce. And of course, some people are free to think that this is not any different than making a ROM hack, which I think it is because the ROM is not modified and it's all just done through gameplay and glitches. But some people will say, well, Nintendo didn't make all of this. Nintendo didn't make this here together music, so it's just just something that the community made. But a lot of people felt that this was really special, and it did something emotionally for a lot of people. So I was happy about that.
Yeah, and all this patching that you do is at the binary level. So how do you keep track of these things? I can imagine just opening a ROM in a hex editor and staring at bytes, but that's not how it goes. So how do you make sense of like where you will want to patch things and when you will want to patch things and how they're going to impact other paths in the code? In other words, how do you navigate the fact that you are not working with source code, but not working with a binary that you're patching?
So the short answer is that we have the decomp source code, and then the disassembly of the actual 1.0 version. So actually, the decomp is a decomp of the GameCube Master Quest debug version, which is a version that leaked back in like 2008. It has all the debugging symbols left in it, and that's why they decompiled that version. So the decomp isn't actually a exact match for the 1.0 cartridge, but we have the disassembly of the 1.0 because of course you just put the ROM through a disassembler and it spits out all the instructions. So look at the C source code, figure out what is the corresponding function, because all of the addresses are totally different because it's a different version. So find out where the function is, read enough of the assembly to figure out like what instructions are doing the part that you want to change in the actual source code. And then if the change is small enough that it can be done directly like in line, because you can't insert anything that would move everything else. So if you can just overwrite a few instructions and change the behavior, then you just do that. And when I say just do that, then that means in the case of code, if it is code for like the system or the engine or anything like that, all of that code is just loaded once at the beginning and then it's kept in RAM. So we just write like the commands for the injection system to just tell it to overwrite that one time, or even more, those will be in the statics. And then when we run statics, when we run the first version of that, it'll just have code which will patch the other code. If the code is like in an actor, which is loaded dynamically, then that would be, we set it up in our list of ROM patches. So whenever it loads something from ROM, it goes through our list. If it finds a match, then it goes through and applies that patch. And so that would overwrite some pieces. So for example, I can show you the player actor. Where is this? So this is the patch file for Link. So this is a custom sort of assembler format that is by a Python script that I wrote that takes base address of Link, and then like at this address, we want to replace it with this function. Or then for, let's say for scenes, not this function, but that assembler instruction for scenes, we want to patch a scene. Let me find the right one that has a room patch. Yeah, scene patch. So then it can also do like base address of 0 and then at address 2580 include this binary, and at this address write this byte, and at this address write this short, and that kind of thing. So this is basically a custom assembler that produces diffs, binary diffs in a format that our code injected into the game can understand and apply. So,
that is fascinating.
Yeah. So that's how we patched assembly and data in existing things. And then of course, if we want to put in like a totally custom actor, then we would just like take an unused entry in the actor table and fill in, oh, this is a legitimate actor, here is its address on the ROM, and then the game will just load that and set it up.
Yeah, I guess my question was more to like, where do you get the magic numbers from? And I guess the answer is from looking at the source and the compiled version for a while. If you look at it for long enough, you start making sense of it, and then you just find the addresses that you want to patch.
Yeah, so sometimes finding, first of all, I'm not the first person to come along with this game. There are spreadsheets of like functions and the address in debug ROM and the address in 1.0. And so of course, if it's in there, you just find it in there. Then there's some things which are either not in that spreadsheet or like are actually different in the different versions. So like the crash debugger is different in the 1.0 version and the debug ROM. And so when I wanted to make changes to that, even the decomp source code was just, it was kind of related to the final code, but it's not the same code. It's not the code that compiled to that. So that you just have to look at it and sort of get an idea of what's going on, and then look at the assembly and figure it out.
At this point, you must be good at reading assembly, which is a crazy skill to have. I have been programming for the longest while, and assembly is still a bit too much to make sense of. Well,
So
I guess if
what
you
I've
start
actually been
something long
doing-
enough.
MIPS assembler is not super difficult. Obviously, like
it
making
is-
sense of like
Yeah, it is
at
the
an
one I learned in
algorithm
college
level of, like,
actually
you s-
because of this.
Yeah, actually, they even taught it to me, and that was like 10 years ago when I took that in college. But anyway, what I've been doing lately is RSP microcode patches to add extra features. This is like post Triforce %. So we added the cell shading that required a small microcode patch, but I've been doing more. But just to like show you, where is this? N64 tools. This isn't in the right format, but whatever. So this is the game's microcode that runs on the RSP, which is the vector processor, and this like does all of the 3D math for like transforming vertices from object space into camera space and doing lighting and those kinds of things. And this is, if you think it's MIPS-like, but it has a scalar processor that is a MIPS processor, and then it has a vector processor, and they run in parallel. And so this is actually like it's assembly. When you see that like these kinds of things, it's actually running these instructions in parallel. So like a vector instruction and a scalar instruction, vector instruction, scalar instruction. This is like one cycle to do both instructions, and then the next cycle and it does both instructions. And the results only show up 4 cycles later. So you need to have like instructions in between. So like when you put this in V18, it won't be ready yet for 4 cycles. It has a lockout. So if you use it immediately, it'll just stall until it's ready. So you won't get like wrong results if you use it faster, but it'll just stall. And so to write this code, you need to be, it's like, if you think assembly is hard, this is like, you're programming for 2 processors at the same time. One of them is an 8-way vector processor. And then you're constantly thinking about the, like, things coming out later in the pipeline. So yeah, MIPS assembly doesn't scare me.
That sounds amazing to me. And would it make sense to try and write this? I mean, I'm all for the principle of locality, but would it make sense to try and write this as 2 separate things and then interleave?
So if you're watching this and you're in the decomp community and you are not allowed to look at leaked info, close your ears for a minute. The microcode source code leaked. It doesn't mean much because it's only assembly language, so you can just run it through disassembler and get the same thing. But they wrote it in 2 columns. They have the vector instructions and the scalar instructions, and then it would just like run one and then the other. And so that's like way easier to read. But the community doesn't know that because so how this works is that if you're in the decomp or you're in like making an emulator or something like that, if you're making a big thing that needs to exist on its own and doesn't contain any copyrighted content by itself, you need to not look at leaks. Because if you make an emulator and you just do it by reverse engineering, that is 100% legal. Nintendo cannot take down the emulator. They have no legal cause for action whatsoever. But if you look at their leaked APIs and then you make the emulator based on that, then they can take it down. So the decomp needed to, in order to try to shore up their legal position and, stop
the concept
them
of the
from
clean
shut
room.
down. Right, they needed to be completely clean room. So the people who work on decomp can't look at any data, any information that came from leaks. So I haven't contributed to the decomp since after the GigaLeak happened. So, I've looked at the leaks and, I've been very interested in all of that, but then I can't look at the decomp and then I can't like share any information with anybody who ever works on the decomp that came from any leaked stuff. So they don't know that it was written this way. So it has to continue being written not that way. But
and do we know what tools they had back in? I mean, since we are talking about the way things were developed, and since we are in this moment where people who are working on the decomp need to take a break, do we know how they
I
did?
don't think there will be anybody who's watching your stream. It's like 100 people, and probably none of them are going to overlap with this. But anyway,
Yeah. So do we know what kinds of tools they had to work through these kinds of problems? Not only the code problems, but also the problems we were talking about of syncing things, reloading a scene to see how it looks like. Maybe they had some kind of tool that would do this dynamic patching, or do you think that they just like burned something and played with it?
so I think a lot of this is not leak info. We like hardware, when hardware gets out there and it goes on eBay, that's not like leaked info. So there's several different types of development hardware that existed back then. Some of them are basically just flash carts, just bigger versions of what we have as flash carts now. Some of them were cartridges that then had a cable that connects to the computer. And so you don't have to like separately flash it. You just run some command and it uploads it and then reset the console, and then you're playing the new game. I don't think they had any. Well, okay. So then they also had a custom SGI machine. So this was most of the N64 development was done on SGI machines because it's the same architecture. They had this custom machine that had a hacked up version of the N64 motherboard, or like the V1 motherboard, as an add-in card in the computer. So it was like even more directly integrated. Like the computer's CPU could write to the game cartridge, which was a bunch of flash, or it was actually a bunch of DRAM. The game cartridge is a bunch of DRAM, and then the N64 console's RAM was a separate RAM. So they actually had tooling. They had everywhere in the debug ROM, there's printfs basically, or the equivalent of that. So when they were running the game, they had a console window that was printing out debugging information from the game constantly. And they could do like normal debugging things like, single step and read memory and all of that kind of tooling.
Oh, that's so smart.
Like directly on the hardware.
But that's not the kind of hardware you can get on eBay, I don't think.
You can get, if you pay like $5,000, then yeah, you can get this. Because there's a handful of them that are out there. But that's kind of useless nowadays because the tooling that we have now is
much better.
The flash carts that we have now are as good, if not better, and then just infinitely more compatible. And then, emulators, obviously most ROM hacking stuff is just done on emulators, and then you don't need to worry about any of this hardware stuff. But yeah, I don't know if they had live patching beyond the just, we can change some RAM values if we want. I don't know if they had like, recompile just this one piece of code and then insert that or anything like that.
Right. How many stars had to align to make this possible? I imagine that there are so many aspects to the code injection and everything else that happened that, like, if one byte was wrong, it wouldn't work, this kind of thing, especially with the bootstrappers and everything. So how many stars had to align to make this happen?
So let me go through this, see if I can do this in a pretty comprehensive way. So the basic arbitrary code execution exploit comes from the fact that code and data for actors are both loaded into the same heap. If they had not done that, there would be no ace. And then, of course, you need a glitch that allows you to use something after it has been freed. The one with Link carrying things is the first one that was discovered, but there has been another one since then also. It's called SRM, stale reference manipulation. But there's actually another use after free exploit that is known now that is used in any percent that we didn't use. So if that star hadn't aligned, well, a second one would have been eventually found, a second like entry point for this. Then the next thing that I guess had to align was that executing controller input as code was sane. So there's the state of all the buttons on the controller is 4 bytes. It's one word. And then there are 2 bytes of other data in between. There's a status, and then there's a dummy byte, a padding byte. So fortunately, the status, if all the controllers are connected, is 0. And the bytes that are all 0 encodes a no-op for MIPS, which is very important. So if there was other garbage between the controllers, then executing the first controller input as code would have then run into the other garbage and then crashed. So that had to sort of align. And also, the game pulls all. So as far as I know, I'm not sure every game, but the default OS for the N64 always pulls all 4 controllers. Even though the hardware can just pull 1 controller at a time, the default OS just always pulls all the controllers. Ocarina of Time then zeroes out controllers 2 and 4 because there were some debugging features mapped to controllers 2, 3, and 4. And they, instead of turning off the debugging systems, like actually removing them, they just zeroed out the controllers so you can't press the controller combos that turn on the debugging systems. So fortunately, they left controller 3 not zeroed. And so we can execute 1 instruction in controller 1 and then 1 instruction in controller 3. And we need 2 instructions because one has to be a jump to safety and the other has to be like an actual payload.
The thing you want to do.
So if that was different, if they had zeroed controllers 2, 3, and 4, this would have been much harder / impossible. If there was other garbage in between them, would have been much harder / impossible. Then the other one, this is like the biggest star that had to align. We can execute 1 instruction per frame at this time with this whole setup. 1 MIPS instruction could do something like store word to memory or load immediate value, but it can't both have an immediate value and write to memory. So we need to set up an immediate value in a register on 1 frame, and then on the next frame, store that immediate value to memory somewhere.
Mm-hmm.
Normally, in any sane CPU architecture, that would never be possible, because in between those 2 instructions, there would be millions of instructions that happened. All the register states would be different. There would be no way to keep something in a register across that time. MIPS has a GP register, which just is never used by any of the N64 games. But it's just one of the 32 normal registers. It's just not in the ABI. So we just put it in that register 1 frame, and then millions of instructions later, we get it out of that register in the next frame.
That is crazy. Yeah, I remember.
So if that hadn't been there, then this would have been much more difficult.
Yeah, I remember that explanation from a video by Retro Games Explained or something.
Retro Game Mechanics Explained, yes.
Yes, that channel explains this in depth with visualizations and everything. So,
yes.
Yeah. Do you think that there are more music things that we should look at before we jump into... I would love to see some actual code and try and run something. So I would like to try and switch to Linux.
So
but before
I
we
also
move,
need a break, but I need to switch to Linux. But I don't think there's anything else in terms of music. If you want to see a little bit of code, we can do that.
yeah.
So I'm going to take a break. I have to reboot into Linux.
Yes, and when you come back, do you want to do the same setup with Skype and Discord, or do you want to do just Skype because we will not be listening to music anymore?
We'll have to see how things are cooperating on the Linux side. We can give both of them a try, but I'll be in touch with you in a couple of minutes.
All right, sounds good. See you in a couple of minutes. Meanwhile,
see you soon.
Yeah. I'm, by the way, going to hang up here, okay? Okay, we'll be back with Sauraen in a moment, but I do want to say hello to everyone here on the chat. So from the top, thank you to Mage, Fotis, Bo, Dale, and Ben, and EE33, and Andrea and Nod for joining us on the chat today. And I will see if there are questions that I missed, but I don't think so, right? If I missed some question, I was trying to read the chat as it was scrolling by. If I missed the question, then post it again here on the chat. And while we are taking this break and Sauraen is rebooting and getting into coding space. I will want to share some of the things that I have been doing on my channel in case you are new here. So if you were just arrived because of the Nintendo 64 and music and coding that goes along with that and the Triforce percent stuff, then you should know about the other things that I am working on. I tend to do streams every weekday. Sometimes I fail, but for the most part, every weekday I am here and I'm working on several different projects. One of them may interest you. So I am working on some audio stuff. I am coding real-time audio effects in Reaper using JS effects. And we have some C++ stuff going on our study group. I have been learning C++ along with some people that are here on the chat. And we are doing all sorts of projects from playing around with Raspberry Pis to doing synthesizers, everything in between. So lots of fun there. If you're into the music part of things, I'm sure you will appreciate some of that. We also sometimes do arrangement and composition and recording and mixing and mastering. That tends to go on the IDDQD sound channel. Arya, who is a colleague of mine, has this channel, and we tend to do most of the music stuff there these days, but you should check that out too. And in terms of coding, I have been working on, or I guess in terms of coding that is not related to music, I have been working on this project that we started yesterday. It is a data bending tool. So you take a video file and you put it in the tool, and it is going to interpret the bits that make up that file as if it was audio. It's going to misinterpret the file on purpose, because if you apply audio effects to video files, or if you apply video effects to audio files, or if you pretend that an audio file is an Excel spreadsheet and open it, the results will turn out interesting. In most cases, it's just going to corrupt the file. But in our tool, we are taking care of not corrupting the file, so you get something interesting on the other side. And we started this project yesterday. Another project that I have going on, and I just switch between projects almost every day, so you can always catch something interesting every week. So another project that we have going on is called Kill the Newsletter. It's a web application, and it is a relatively straightforward application. It is just something that you sign up for a newsletter with an email address given to you by the application, and then you receive that newsletter as an RSS feed. For people who like newsletters but don't like receiving them as email and prefer to use Atom readers or RSS readers. So we have that going on. It is a project that I have been working on for almost 8 years at this point, maintaining and changing and updating and sometimes adding features. And lately we have been working on that because the TLS certificate is about to expire, and the thing that renews the TLS certificate no longer works because the certificate authority changed the protocol. So we are working on updating this application, the libraries that it's using, and potentially adding some features and changing the way that things work here and there as well. Oh, and it seems like Sauraen is back. Let me join the call. Hello, Sauraen.
Hi.
You are back, and we can hear you and everything, so I think that we can go with this. Oh, but we don't see you just yet. Hang in there.
You don't see me? I see me.
No, the stream doesn't see you. Now everyone sees you. It's fine. I just had to press a button here on OBS.
You mean right here? Oh, I see what you mean.
Yeah. For whatever reason, you joined the call on a different operating system, so you had a different ID in OBS.
Oh, I see.
You're back.
Okay. Yes, I'm back. Should be mostly the same here. But yes, now I'm on Linux. Fortunately, OBS is a Linux enabled program, so we can use it.
And did
so
you
what?
I'm curious about this. Did you export the scenes and the configuration in OBS in one operating system and load it in the other, and it worked?
No, I just remade it.
You had to remake it. I thought as much.
I mean, it takes 5 minutes.
Oh, really? On my setup, it would take an hour or two.
Oh, I don't have. Again, I'm not a streamer. It's just I have 5 scenes. I have my video capture. I have my screen share, webcam, and then the combinations of them. So pretty straightforward. But yeah. So I don't have a ton of time left today. I can be here for another 20 minutes or a little more than that. But then I got to go. So I'm not sure if we will have enough time for a full demo of we're going to make something and then inject it. But I can go over a few sort of elements of how the code looks overall, and then maybe we can do this some other time.
Yeah, absolutely.
And,
can you do something for me? Can you zoom into the text editor just a bit, because the letter is too small for now, especially because it's going through Skype and everything.
Yeah.
Yeah. I think that looks okay. If someone disagrees, mention on the chat and we can do something about it.
Yeah, I do see on your end it looks a little desaturated.
Yeah.
I wonder if I can do something about that. There's some sort of filter I can add in OBS or something. Oh well. Yeah, I guess this is what you get for now. Maybe there's a high contrast mode I can set up in here. Whatever. I'm not gonna.
Whatever. I think it's readable.
Spend the time messing with that.
Yeah.
Yeah. Yeah. So what do you want to see? You want to see some custom actors? You want to see some static code, some engine patches, bootstrappers?
I would like to start with the bootstrappers, because I think that's where most of the stars had to align, and that's the part that I think is the most interesting to start with.
All right, so there's sort of 2 pieces to this, or there's a few pieces to this. Where is this? Apply patch test. OOT bootstrap. Yeah, so if you want more details about this, please watch the Retro Game Mechanics Explained video. There are links to everything about our project at our website, gettriforce.link. I was very happy about getting that domain name.
The link is in the description for people who don't want to type that out.
Oh, okay. Yes. So there are 4 steps of bootstrapping, and then, well, sort of 5 steps of bootstrapping, but there are 4 separate bootstrapper programs, and then there is a final payload, which is the hyperspeed loader, which is injected by bootstrapper 4. So bootstrapper 1 and bootstrapper 3 are both programs that are run 1 instruction per frame at a time. So bootstrapper 1 is a program that is on frame 1, it will be load immediate value. Frame 2, it will be store immediate value to memory. Frame 3, it'll be load another immediate value. Frame 4, it'll be store another immediate value to memory. And so that set of load and stores is bootstrapper 1. And what that does is that writes bootstrapper 2 into memory. The contents of those loads and stores are bootstrapper 2. And then it will run bootstrapper 2 by jumping to it. So this is the script that is creating bootstrappers. Well, it's creating all of them, but it's specifically creating 1 and 3 here.
I love metaprogramming.
There is a lot of metaprogramming here. So this is add general purpose register 0 and then a hex immediate value. So this loads 2 bytes. Sorry. And then this stores to a offset relative to a particular register. So it matters what the context is when it is doing the arbitrary code execution, because we need to use one of those existing registers as a different register, as the base address that we're then writing immediate values relative to. And so we found some unused memory. It's actually not unused. It is the font buffer. It is where it loads text into for message boxes. But it loads each character into that buffer when a message box is on screen. When a message box is not on screen, it's not doing anything with that memory. So that is where we're writing in bootstrapper 2.
Oh,
So
hang on. I
this-
actually have a
this-
question. I have a question about the way that the controller inputs work, because we see Link doing all kinds of weird movements on the screen while that's happening. Did you have to do anything special to make sure that Link would not look a certain way or do some kind of movement and get into a rotation or coordinate that it shouldn't be, and then it would break the injection? Or you could do any kind of input and you didn't have to worry about what would happen in game?
For the most part, we didn't have to worry about it. We did, as you can see here, it is doing, so this is actually, this is generating a task movie file, which will encode the instruction, the inputs that will do Bootstrappers 1 through 4. And then using Bootstrapper 4 to inject the hyperspeed loader. So it is actually unpausing for 3 or 6 frames. I won't go into the details. Then jumps to a stack restore address for 240 frames while waiting for the camera to rotate. Then holds R to make Link shield. Encodes hold R, which is also a NOP, because it needs to be Link holding R, and it also needs to be a no-op for MIPS. And then once Link is holding R, then we can do the Bootstrapper 1 and 3, and he'll just wiggle around and he won't walk. Because if he walks through a loading zone or walks away, turns the camera back, then it'll stop executing this. So basically he's just in place, and then he can wiggle around.
Yeah, I noticed that it was actually holding shield the whole time.
Yeah, so the immediate value is the control stick, and then the choosing which registers and what the opcode is with the buttons. So that's why we can just sort of, we're alternating between 2 instructions with the buttons and then moving the stick to various positions.
Oh, so that's another thing, actually. The human that would be playing this would not only have to play super fast, but also have 3 arms.
Yes, 3 arms, and then on every frame, put the control stick to an exact value.
Sounds reasonable.
Yeah. And also the control stick can't go to plus 127 plus 127 because it's rounded. But we ignore that. We allow plus 127 plus 127 if it needs that. What we don't allow is that there are 2, this is actually 30 bytes and it fits into 32 bytes. There are 2 sort of unused bytes that are not one is actually a reset, and one of them is a you're going to realign the center of the stick. And so we don't use those. So we do have to do a little bit. That was another star that had to align, is that we could encode the instructions we needed to encode while those 2 bits of the word are 0, because we don't have buttons for those 2. So yeah, this is the instructions, and then it stores. So it writes unpause, jump to stack restore, hold R, stack restore, Bootstrapper 1. This is Bootstrapper 1, and jumps to some stack restore, and then writes this is some offset, and this is the data. Then runs Bootstrapper 2, which is what got injected with this, and that is here. So there are actually 2 different. This thinks this is ARM assembly rather than MIPS, which is why it doesn't like this. That's all right. There are 2 versions of this. There's the actual live version, and there's the one with our shortcut. So since I am not at the speedrunner at the level of save state, I can't actually do this personally on a real unmodified cartridge. So we have a modded copy of the game that doesn't have any of the data injected, but just has a very small mod that will automatically jump to controllers.
How good of a speedrunner are you, RTA?
I have never tried speedrunning. I've done some of the glitches, and like Door of Time skip, I can do it in maybe 15 minutes of trying over and over and over. After 20 tries, I can get it. So that's how not good I am. So, but the whole idea of TAS is that it turns this from a human performance challenge into an engineering challenge. So, yeah. So this is Bootstrapper 2. We restore. We're pushing a value onto the stack because we need another register for Bootstrapper 2 to execute. This is determining whether it's running from ACE or from pad manager. Pad manager is the code, the next code that we're patching. It's part of it's the controller manager. That's what we're patching here, because this same thing will get jumped to once the idea is this is changing it. Instead of doing ace from the ace exploit, we're doing ace by just directly jumping to controllers. Every time it pulls the controllers, it just directly jumps to the controllers. And so it will end up executing this in both contexts. And so the code has to detect which context is currently executing from, and it needs a different stack restore depending on which context it is. So that's what this is doing. If it's not in the ace context, it's already done its thing. So it returns branch to in ace context, which is here, and it starts doing this. So now we have cache time. So these are the instructions which are normally zeroing controllers 2 and 4, and we're changing them to jump to OS write back decache, put in an address for the decache, jump to invalidate instruction cache, put in a value for that, and then jump to the controllers and put in a particular upper value for the controllers. So this is clearing, flushing the caches, and then jumping to controllers with some specific values for them. And then this is code which is writing these instructions over other code. So this is another level of metaprogramming. This is not these instructions. This is code that writes those instructions.
I see.
And then write the we need to for the fast loader payload, we need an initial value for the address that it's writing to. So we need some variable in RAM that's holding the address for where we're writing the next piece of that payload to. And so we initialize this counter. This is the start of the expansion pack memory. This is somewhere high up in the expansion pack memory. The expansion pack is unused by Ocarina of Time, so we have an extra 4 megabytes of just free RAM to play with. So it initializes this counter. And then depending, this is Bootstrapper common. So depending on whether we are in the real live version or the shortcut context with the cheat to get ace. And again, for those watching, we did not use a cheat at SGDQ. We used a real ROM. I know everyone loves to think that this is all fake, but it's not. It's just that, I'm not a speedrunner, so it has to be fake by me. So with the real RTA version, then after it does all of these, it has to stop the original ace. So this is restoring the value that we used the exploit to overwrite that ends up being a jump to all of this stuff. This is fixing it. And then jump to the end of a function that restores the stack correctly.
It's so cute that you have to unpatch your patch.
Yeah. Well, I mean, otherwise, then you have... It's still, it's going to... We don't want to be executing controllers as code from two different contexts at the same time. It's just like, you gotta shut the door after yourself, basically. Yep. So then we have... it does the same thing, and it injects Bootstrapper. It runs Bootstrapper 3, which is injecting Bootstrapper 4. And then Bootstrapper 4 is... Whoops, that's opening in the wrong program. Bootstrapper 4 then is a program which will then get run every frame when we're using Bootstrapper 4 to inject the hyperspeed loader data. It is taking bytes from controllers 2, 3, and 4, like the whole thing of controller 3 and 4, but then just a couple extra bits to fill in the empty bits in controllers 3 and 4, because there's those 2 missing bits. We have to take 4 bits from controller 2 to fill them in. Take this address counter, store the 2 words that we've loaded from the controllers, increment the counter, store the counter, and then 0 controllers 2 and 4 again, because that was what we overwrote. So we have to do that. Then that gets run. We encode controller input that jumps to Bootstrapper 4, and then with the data for Bootstrapper 4 as controllers 2, 3, and 4. So then it will load the binary of hyperspeed loader as the payload there and inject that, and then jump to the entry point of that, and that's it. And it just lets go of the controllers.
It is crazy that all of this works, but it's not a lot of code. It is about 1,000 lines overall in all the files we looked at. which is amazing given what it does.
Yeah, that's not even, this isn't even 1,000 lines. This is like 30 instructions here, and then this is a lot. But so, the Bootstrapper 1 and 3 are just like repeated inputs of load this, store this, load this, store this. I can show you what those actually look like. It's in their RTA. So these are the actual inputs being put into the console. This is a text ASCII version of the task movie file. So this is start is being pressed, unpausing. This is controller 3. This is encoding with minus 12620, that this is encoding a jump to a function which will restore the stack, because we don't know at what time here it will start executing this as code. So these will all be no ops, and then this will be a jump to some function that will restore the stack. So it does that for a while and just sits there and waits. And then it's still jumping to the stack on controller 3, but on controller 1, this is now for 6 frames, 6 VIs, which is twice, 2 frames it's executing each instruction, because if there's a lag frame, one of these will get dropped. But if we do it twice, then that's okay. So this is like the load immediate, and then this is the store word. This is the load immediate, store word. This is actually some load immediate. This is probably like a commonly used value. So then it stores that word 3 times to avoid having to load it multiple times. So little optimizations there. Load immediate, store word. This is probably zeros or whatever. Anyway, so it does this for a while. That's writing in Bootstrapper. That is Bootstrapper 1 executing as writing in Bootstrapper 2. Then this is jumping to Bootstrapper 2. Then this is now every frame, load immediate, store word, load immediate, store word, load immediate, store word. This is Bootstrapper 3, it is writing Bootstrapper 4. Then this is running Bootstrapper 4, jumps to Bootstrapper 4. Here's the extra 4 bits, and then this is the full, rest of the bits for 64 bits worth of data for. This is now Bootstrapper 4 is running and injecting the code for the hyperspeed loader, and the rest of this is the hyperspeed loader payload encoded as, those controller inputs. And then at the very end here, this is jumping to the beginning of that, and that's the end of the task movie.
And even that is not ridiculously long. Amazing.
This is 1,138 frames.
Yeah, it's not.
And that's VI frames. That's 60 frames per second frames, not 20 frames per second frames.
Right. Amazing. Okay, so we don't have much time left, but there is another thing. There are many things I'm curious about, but I noticed
we'll come up with another time to do another session, and we can do more code stuff.
Awesome. Yeah. So there's just one more thing that I remember seeing in one of your interviews, that the thing that catches the tweet chat and puts it in the controller to go to the N64, you started firing this and it was like an npm start and a Python script. So I imagine that there is a whole patchwork of scripts to make this work. Can you give us an overview of how that works? Because I guess that's another part of the magic of the run.
So the Node.js side, I do not know any JavaScript. It was actually TypeScript. I don't know how to, I can sort of read it, but I don't know how to write the language. So that was written by the Moss3212, who is one of the regular TaskBot contributors and has written the software for injecting Twitch chat into other games before. So he came on and did the Node.js side. So that connects to the Twitch API, gets the chat messages, and does the bad word list filtering. So we made a bad word list from 3 existing bad word lists. We concatenated them together and then added dozens of words of our own. And it is very strict. It is way more strict than you would normally use on a forum or whatever, because even if there's a part of a word, you have, let's say, assemble, and then it says ass in it, we would block that. Right? Because we have one chance to get this right. And if we get some X-rated, even if it's technically not a bad word, but it's a description, the username is a description of some X-rated thing, shows up right in the middle of the screen in Ocarina of Time, then we are going to be in trouble with GDQ and maybe with Nintendo. Like if there was anything that would get them to come after us, that might be it. So, we had, again, and we have one chance to do this. It's like it either works or doesn't. So we put in, very strict filtering. But if your username gets filtered, you don't get excluded from participating. It replaces the bad word with random letters and then just puts you in the back of the chat so you can't really see the text too clearly. So your message still comes through because we didn't want to exclude people. So then that transmits the resulting usernames and information, because so it's the username, it's the message content, but then the next script will remove the message content. I'll mention that in a minute. The user's badges, the emotes that they used, the color of their username. There's a few other things. It puts it into a JSON file and then sends that over a local socket to the Python code, which I wrote, which I can pull up, but it's not super interesting. This is, it's all released. In fact, the JS and the Python stuff was just public even before Triforce% happened. It was just on random repos that nobody looked at. So,
How difficult was it to keep all of this a secret, given the length of the time it took and the number of people working on this?
It was a bit tough, and especially since the TaskBot community is very open source focused. They're very public, like everything that they do is public. And Dwango had a lot of resistance to doing this as a secret project. In fact, I mentioned we're going to be doing something in a couple of years or next year or whatever with playing against humans on a real game console. You can just join the TaskBot Discord and find the channel that's about that project and then see everything about that project. But that is not how the ROM hacking community operates. Everything is completely locked down. Nobody's using real names. Everything is like, if anything, if you work on a game, a fan game for 5 years and then put a trailer up a week before the game comes out, there's like a 50-50 chance that Nintendo will shut it down before it releases, meaning that your whole effort is destroyed before it can even get out to the world. So that was the issue, is if this gets out there, well, it'll spoil things for people, but it could also get shut down before it actually happens. And that would be so catastrophic. I mean, it would literally, all of this effort of thousands of hours would just be down the drain. So yeah, it was somewhat tough, but whatever.
I was under the impression that channel about the Triforce% on the Discord server was not public before the run, but it was?
It didn't exist. It was
okay.
created right after the run. The Triforce% was developed in a totally separate Discord.
I thought as much, yes. All right. Okay, so we are already over time. It has passed more than 20 minutes since you said you had 20 minutes. So I think it's time for us to wrap up this time. But if you are up for it, I really want to do a part 2 because there's so much we haven't covered yet. There is so much about the cell shading. We need to look at the code that does that. You patched some of the micros. I need to see how that works. It's just amazing to me. And I am sure that people watching agree with that. So thank you very much for joining us today. And thank you everyone who is watching this either now and participating in the chat or in the future. I really appreciate you all being here, but I will let you go now. And
sure.
I'm looking forward to talking to you again in the future. What you did is really amazing at a technical level, as well as, and probably mainly at the artistic level. So really amazing work. Thank you for all you did, and thank you for joining me. You're very generous with your knowledge and your time. And I will be back next week. Have a great weekend, everyone. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.